This interview is for information only and should not be considered as investment advice or a recommendation to buy shares in the company featured. Welcome to this StockBox interview.
Joining us today from site at the Monte Muambe project is Cedric Simonet, the CEO, of course, of Altona Rare Earths. Cedric, it's great to be catching up with you on site via Starlink. You look like you've been very busy in the field. How's it been going? What are you doing in the field?
Well, Mark, very nice catching up. I am on site at Monte Muambe with our team. As we previously announced, the last RNS on the gallium discovery, we had two RNSs about the gallium discovery. In the second one, we said that we found some gallium in soil anomalies, which were quite extensive, three significant anomalies. So our first step was to go and ground proof these anomalies, ground truth them, which means we go in the field and we have a look at what we can see, what we can observe on the ground. And especially we were very interested in this because some of these anomalies seem to have some geometric connection with high-grade fluorspar, so we thought this could lead us to more fluorspar. And to get a better understanding of the distribution of the gallium in the soil, we are currently doing in-field geochemistry. So for example, when in an area where we had 100 meters between two soil samples, we are now taking samples every 50 meters or every 25 meters to have a better resolution.
And you're doing that on site then? You can actually do that chemical analysis on site?
Yes, we have a portable XRF analyzer and we have equipment to prepare samples. When we acquired this analyzer, we did a lot of quality control and orientation work to ensure we knew what is the exact meaning of the results. And that's why some of our PXRF results could even be used in a CPR to define the shape of the ore body. So we've got a lot of confidence on what we are doing. We are following very strict quality control procedures. And the benefits of being able to do the analysis on site is that you see your results today, the next day you can plan how you are going to do the work according to the results.
Yeah, okay. So you're on site doing what you call ground truthing. So you're taking samples looking for gallium, which is you've associated with the deposit of fluorspar.
Exactly. We are looking both for the fluorspar and for the gallium. Visually, you can see fluorspar. It's a mineral which is quite easy to identify just visually. You can see if there is fluorspar, you can get an idea of the grade. The gallium, we cannot see. It occurs at a very low concentration, but thanks to the XRF, we are able to measure on site the gallium contents in the soil and in the rocks.
Excellent. Okay, good. So how long are you there for? When you leave, what would be the situation on the ground?
Yeah, I'll be here just for a few days, basically supervising and checking. And I like to see things, I'm a geologist. But my team is still going to be here for another few weeks. They've been here already working for several weeks until we finish the infill soil sampling and until we finish mapping these fluorspar occurrences that we are finding thanks to the geochemistry.
Okay. So you'll basically finish off with a good map, a good visual idea of where the gallium and the fluorspar are, which will then, I guess, feed into further studies.
That is correct. So the typical next step, once you find either better defined gallium anomalies in soil or once you find fluorspar outcrops, the next step is going to do trenches. We actually already have some trenches going on some of the fluorspars that we found. And ultimately, we will have to do some drilling.
Yeah, okay, good. Well, let's get into the news today then, because of course this is quite significant. Last time we spoke, I know you were awaiting the fluorspar MET results to determine the gravity flotation process, if you could make metallurgical fluorspar or acid fluorspar or Acidspar. So these results that you've announced today, you've achieved 93.62% CaF concentrate, which you say is close to Acidspar standards. So how significant is the shift to targeting Acidspar, and what does it mean for the project's proposition?
Okay, so initially we were targeting metallurgical grade Fluorspar. And metallurgical grade Fluorspar is a product which typically is less than 80% calcium fluoride, and also it comes in lumps. For consumers, for clients, what's important is not just the grade and the impurities, but also the shape of the product. Metallurgical Fluorspar has to come in lumps because of the way it's going to be used in furnaces for metallurgy. However, acid grade Fluorspar is used to be dissolved to produce hydrofluoric acid, and so it's required not in lumps but in a very fine powder. So what we did initially was to look at MedSpar, and we wanted to look at gravity concentration methods to see if we could produce metallurgical Fluorspar. So to produce that, you don't want to grind or to crush your material too fine. So we crushed the material to 2 millimeters, which was still usable for MedSpar. But unfortunately, at that size, we didn't get any concentration. This is because there is something called the liberation size, and to be able to free the Fluorspar from the other minerals, you have to go finer. So that excluded the possibility of doing MedSpar. However, we did also the other test, which was aimed at looking at the possibility of doing Acidspar, and that's flotation. And this first flotation test worked very well. We had to fiddle a little bit first with the reagents. The first test was not successful. We changed the reagents based on experience from other Fluorspar deposits. And we got these results, which are very, very good and very encouraging. Out of this, okay, you mentioned the grade of 93.62%, still a few percent short of the acid grade Fluorspar concentration, which is 97%, but we will get there. And the other important thing is the impurities. You want the impurities to be as low as possible. You want them to be below the maximum level allowed by consumers, by clients who are using this Fluorspar. And already several of the anomalies are below the required level, even though it's not a completely finished product. Mm-hmm. And the other impurities, the grade has been reduced in a way which shows us that we will be able to reduce them and to take them below the maximum level allowed, acceptable by the clients.
So this is good news then. You've got higher quality and it fetches a higher value on the market. It needs to get an extra 2 or 3% in it. How do you do that? Is that deposit related or is that through processing?
So there are different ways to do this. When you do flotation, you have a first stage which is called a rougher stage, and this is what we did. And then after that, you can have several steps of cleaner stages, and some of these steps may involve regrinding the product as it goes. So we are now going to do more advanced metallurgy to determine the exact flow sheet to get to 97% with all the impurities below the acceptable levels. It's a relatively simple process. We might also use other methods on the concentrate, like for example magnetic separation to remove some of the iron. It's pretty straightforward. Flotation is a process which is well known for Fluorspar.
Yeah, okay. No, that makes sense. So flotation, I understand that process quite well. Maybe what viewers don't, but yeah, you have basically float tanks, don't you? As you say, you start with the buffer. There's also maybe called a rougher as well, I'm not sure. And then you go through different cleaner cells. And all the time it's purifying the product. Yeah. Also of note when in the RNS was that I noticed the scope had shifted from 15,000 to well, it was 15,000 to 20,000 tons per annum of MedSpar. But now you're talking here potentially of 50,000 tons per annum of acid spar over 12 years. So, I mean, what's driven this and how can you sort of confidently say that at this point?
Well, as we wrote, this is still conceptual, but the gallium, following the gallium anomalies, as I said, has taken us to more new Fluorspar outcrops, which we didn't know before. The project has a historical resource, Fluorspar resource, of 1.6 million tons with 19%, which was defined back in 2010, 2011. So we know there is this zone which has fluorspar, but now we are finding more fluorspar. And we've already found 2 zones with more fluorspar outcrops. So there are 2 news for us. One is a metallurgy which shows that we can produce acid grade technically. The other one is that we are finding more fluorspar on the ground. So 3 million to 4 million tons is conceptual, but it's backed by what we are seeing on the ground and the fact that every day, as we are in the field, we are finding more fluorspar. Okay. And so when you take 3 million tons at 35% grade to have a reasonable grade, and you consider to be very conservative just 60% recovery, it will probably be more. You divide this by 50,000 tons per year, you get more than 12 years.
Excellent. Okay. And in terms of seeing... Sorry, Cedric, go on.
Sorry, just for those who are not familiar with fluorspar, 50,000 tons is not anymore a small-scale mine. It's like a medium-scale mine.
Okay.
And 100,000 tons per year would be a large scale now.
Right.
So the project really takes one step up by these discoveries, both the met and the discoveries on the ground.
Excellent. So in terms of developing this further, you're working on the flow sheet, doing further met tests to refine that process. You're also going to start doing a JORC-compliant MRE. So is that the point where we can start to see some real backed numbers when you can start going through those processes? Will you look to get a PFS out initially?
Yeah, as far as the fluorspar is concerned, the next steps of significant information are going to be the advanced metallurgy with the flow sheet. This is going to tell us how the plant is going to look like. This is going to tell us what the CapEx is, okay, and the mineral resource estimate. That is going to feed into a scoping study, like we wanted to do for the metallurgical grade fluorspar. It's going to be different. Scope of the project is different, it's bigger, the plant is different, but the flotation plant is also not something very expensive. So the strategy of trying to fast track from a scoping study into a DFS which is implementable and financeable remains the same.
Okay. And I think previously you mentioned that there was opportunity for perhaps a low capex rapid setup for fluorspar production, potentially using equipment from China. So does this now focus on the Acidspar? Does that change some of those capex things or timelines?
The capex and the timelines will change a little bit, but they are not expected to change a lot. Again, that's because it remains a simple project. Flotation is a little bit more advanced than gravity concentration, but it's still just a simple mine with a flotation plant.
Right. Okay. Good. So is it sort of fair to say that Altona is an Acidspar company now that has gallium and of course rare earths as well, but really Acidspar is the moneymaker?
Well, I think Acidspar has got a lot of potential to be a moneymaker in the short term, right, but I don't want us to forget our Cesana copper-silver projects in Botswana, which is a grassroots project, but the timeline to a discovery, a potential discovery, of course, we don't know yet, but the timeline to a potential discovery to drilling is relatively short, and that could lead also to some monetization avenues for Altona in the short term.
Okay, interesting. So just finally then, I've covered quite a lot here, I know, but finally, what can we look out for as investors next? Is it news from the copper projects, or is it also some big catalyst news from Monte Muambe here?
So we have work ongoing on the ground, and part of the RNS that we published today is reporting on this work, and this work is going to continue. We are sending several batches of samples to laboratories for more metallurgical testing, not just for fluorspar, but also for the rare earths and the gallium. If you remember our RNS about gallium, there was a lot of information, but one of the things with the gallium is that some of it is associated to the rare earths contained in rare earth resources. And now we want to confirm that this gallium can be recovered in the flotation process together with the rare earths. And we believe that this is what is going to happen. And then some of the gallium potential is with these gallium anomalies on which we are doing infill drilling right now, with the aim at narrowing down possible high-grade gallium veins, which may be exploitable not even as a co-product or as a byproduct, but as a main product. So there's going to be news about this field work on the Fluorspar and on the gallium. There's going to be also news on the Cesana copper project. The transfer of the license to our local subsidiary is ongoing. You can see that on the Botswana mining cadastre. And separately, we are in the permitting phase for the airborne survey. And if these permits go through as fast as we want and as fast as we are aiming, we should have the airborne survey ongoing within the next few months.
Okay, excellent. Good. Well, thank you as always for your time, Cedric Simonet, the CEO of Altona Rare Earths.
Thank you, Mark.
If you enjoyed this interview, then give us a thumbs up, a like or a retweet. Subscribe to us on YouTube or follow us on Twitter and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at stockboxmedia.com. Thank you for watching.